Hi friends, welcome to the Unit 5 Day 1 notes. This one talks about really ratios, and it just gets into ratios and proportions. A lot of this is going to feel like it's review kind of, and it's because a lot of what this unit goes over is just real world examples of things that you're probably already using or you've used in the past. It just reinforces that. A ratio is just a comparison between two qualities. So here, ratio, it's just a comparison between two, I think it said qualities, it's quantities, definitely numbers, not characteristics. Comparison between two quantities, or two amounts, two numbers. Fix my video here, there we go. And then this is always a fraction of some sort, usually. It's a fraction. There's other ways to write ratios, but if you think about it as a fraction, then you're good. So the word fraction should come to mind when you see ratio. So the ratio of two numbers can be written in multiple ways. One of the ways that we write it, as we talked about, is the fraction. So it's like a over b. So that's one way. You can also write it as a and then this symbol here, which is called a colon, a to b, and that's how you read it. And then we can actually just say it as like the ratio of a to b, which is the same thing here. So this is all the same. It's all said the same way, a to b, ratio of a to b. It's the same thing. It's just how you write it, different ways to write it. So here, on this example, if I want to talk about writing a ratio expressing the slope of this line, line L, remember slope is rise over run. So how far you move up and down, and then divided by or over. This is when we say over, how much you move left or right. Again, I don't like to say the word over when we're talking about slope because you don't know which way over is. There's the formula in case you forgot. So if I just plug in these numbers, substitute if you will. So I'm going to substitute. So y sub 2, so that's going to be 3 minus y sub 1, so minus a negative 1, divided by 4, and then minus negative 2. So 3 minus a negative 1, it's going to be 3 plus 1, so that gives us 4. And then over 6, and then always reduce. So this ratio is 2 to 3. So we're going to rise 2 and run 3 in the positive direction. So that tells me I'm going to rise or move up 2, and then run or move to the right 3. Here we're simplifying the ratio for example 2. When we simplify ratios, we're always talking about the final number or value that we get. You should not have any units when you're simplifying this. So this says $12 to $16. So maybe this example is talking about for every $12 that you spend on making a product, maybe making a candle, you earn $16 when you sell it. So that's why we're talking about this in this context. So it said like what's the ratio of your profit? Well, if I simplify this, and then I can actually simplify vertically. So I do $12 over $16. And then if you notice, there's a number that goes into both. 4 goes into both 12 and 16, goes into 12 3 times, goes into 16 4 times. So we're left with 3/4. The units always should cancel, so we're just left with the ratio of 3 to 4, 3 over 4. Same thing's going on here with this inches squared. So this is going to be, again, the largest number that goes into both. In this case, this is 8. 8 goes into 32 4 times. And 8 goes into 8 once. So this is 4 to 1. Now notice, normally we say go ahead and reduce this fraction. This is a ratio. Again, this is a ratio, so it has a little bit different rules for it. This is sufficient. You could also do 4 to 1 this way. Remember, all of these ways are valid. So for C, we've got centimeters and centimeters. Notice I'm checking that at the very beginning on each time. So we'll talk about that when we hit one that doesn't work that way. Let's see, 2 goes into both of these numbers evenly, so this is going to reduce down to 3/7, or 3 to 7. I'm just showing this both ways on these problems just to remind you. Both are sufficient, either of sufficient, however you show. On D, now we're starting into one that isn't. Oh no! So 10 inches and 2 feet. So you cannot reduce this until you have the same value in the units. So you need to have the same units. So how many inches are in a foot? So we want to notate that. In this case, it's 12 inches are in 1 foot. And so what I'm going to do is then multiply this by 2. So I'm going to take 2 feet. So 2 feet times 12. So 2 times 12, and that'll convert 2 times 12, that'll convert it into inches. So this is going to be 24 inches. So 2 feet is the same as 24 inches. So now I can do 10 inches over 24 inches. And now I can reduce because I can eliminate the units. So if I eliminate the units here, let's see if I can make this a little bit crisper. Nice clear, there we go. Fantastic. So then let's see, 2 goes into both of those. 2 goes into 10 5 times. And 2 goes into 24 12 times. So this is 5 to 12. So that's the ratio. Here we've got gallons and quarts. So there are 4 quarts and 1 gallon. 4 quarts and 1 gallon. So here to get this value, let's go ahead and convert gallons into quarts. If you notice, I'm converting these to the smaller of the two. So a quart is smaller than a gallon. And that helps us reduce it a lot easier. So let's see. So I can do 3 times 12, or sorry, 3 times 4, which is 12. 3 times 4, so that'll give us 12 quarts to 10 quarts. And then if I write this vertically, 2 goes into both. So now, let's see, 2 goes into 12 6 times, 2 goes into 10 5 times. So 6 to 5 is my ratio. And then here we have ounces and pounds. There are 16 ounces in 1 pound when you're talking about wet measure. So 16 ounces is equal to 1 pound, lb. So then I can take 16 times 2, that gives me 32 ounces. So I have 28 ounces to 32 ounces. Or if I write it as a fraction, 28 over 32. So my units are going to cancel. 4 goes into both of those evenly. Yes. So 4 goes into 28 7 times. And then 4 goes into 32 evenly 8 times. So this is 7 to 8. Now we have example 3. So this one's find the ratio of the width to the length of the rectangle, then simplify the ratio. So the width is first, the length is second. So when we're talking about width to length, that means width is going to be our numerator, and then length is going to be our denominator. Generally width, we talk about how wide something is from left to right. So we're going to call this part the width, width. So for here, this is going to be 12 centimeters to 4 centimeters. Again, I'm writing the units because I want to see if they cancel. So here, boop, boop. And then 4 goes into both of those evenly, so that's going to give me 3 to 1. Same thing here, so now we have 10 inches over 6 inches. Cancel. So these simplify. My inches simplify. Let's see, 2 goes into both, so this is going to be 5 thirds. And then here I have 18 inches over 1 foot. Wait a second. Can't have inches to feet. We need to convert. So let's convert the feet to inches as well. So this is the same as if I had 18 inches over 12 inches. Now I can reduce. 6 goes into both of those evenly. So that's going to give me, and those simplify too. 6 goes into 18 3 times. 6 goes into 12 twice. So that gives me 3 over 2. All right. So now we're going to jump to the proportion definition and then the examples for 4 and 5 in the next video. So I will see you there. Bye, friends.